I'm also disappointed that he works in enterprise security and there's no red tunic. Okay,
I'll bring it next time.
Yeah,
Thank you.
All of these security measures actually don't make much sense if the password that goes to it and the authentication that goes to it is like password 123 or let me in, and which sadly enough is kind of the case, a lot of cases, and that's why my colleague Rob Trace will trace the outline right now of what we're doing with strong authentication and the roadmap to FIDO. So I promised more dog jokes. Here we go.
Good morning. My name is Rob Trace. I'm a program manager on the Edge and Web Platform team. And like I said, we're going to talk a little bit about authentication and how we can, that was the wrong button to touch, how we can integrate Windows Hello into your applications. So looking for a demo. There we go. When we go out on the web today, this is pretty much the experience we typically see, right? The first thing that happens is we get asked for a username and a password so that we can have a custom experience, whether it's we're on our banking site and we want to see our own accounts, or whether it's just a site that wants to go ahead and decorate itself based on our preferences. But nonetheless, we go ahead and we ask for a username and password. What's coming up, or what you can do today, is that you can actually change over from using a username and password to using Windows Hello. And it starts with a registration process. So here I'm going to say, yes, I want to start using Windows Hello. And what happens is I get prompted right away for the Windows Hello. Now I'm using the facial recognition feature of Windows Hello. So the camera on that just took a picture of my face and said, oh, there's Rob. And he's ready to go. And so I can say, OK. And that goes ahead and registers me with the site and logs me on. Now after that, I can go ahead and log out. And the next time I come to the site, I'm not presented with a username and password, but now the password's gone, and I can go ahead and sign in with Windows Hello. And again, it'll prompt me for the hello, and it very quickly recognizes my face. But you can see I'm not using some cooked demo here. The minute I walk away from it, it goes ahead and it starts looking for me again. I have to actually be standing in front of the camera. It verifies that I am the user at the keyboard, and then it goes ahead and says, yep, you're Rob, you're OK. And you say OK to that, and it logs you onto the site. So what's possible today with Windows 10 is to integrate with Windows Hello and use a stronger password. So let's talk a little bit about it and how it works. That's the end of the demo, so we'll switch over. Remote. All right. There we go. So like we said, username and password is kind of the language of the authentication on the internet. We use it because it's something that a user can actually remember, right? It's something that they understand the concept of. OK, here's my username, and I have this secret password that I use. And no problem, I can just go ahead and set up my account with this site, and I can log on with my secret. But using that secret has a few problems. In particular, people like to use things that they can remember. So here's a list of the top guessed passwords on the internet, right? You can see that 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, they show up over and over again. People use these things because they can remember them, but they aren't particularly strong credentials. The second problem is that I have a password and I can give it away. My kids learned this really early with their phone. They gave the password away to their friends, and all of a sudden their phones have got goofy pictures on them, and they don't know what to do with them. First thing they had to do was change their password, and they learned never give it out again. But we're people, right? We get tricked sometimes. We lose our passwords because we believe someone who calls us on the phone or sends us an email. We just happen to be trusting individuals. So once that happens, then comes the real problem. So now I have all of these passwords stored up, hashed, secured on my site, but if that site gets compromised in a bad way, they can lose a whole database worth of passwords. Me, I can't remember 50 passwords. So I compound the problem by reusing the password over and over again on multiple sites. And my account tends to be the same thing because I want to remember it as I go from site to site to site. Once that password is stolen, an attacker can actually have access to more than just the site that got compromised or the time that they compromised me. So overall, the goal here would be to move users off of passwords. So real briefly, we're just going to walk through the model of how the password authentication works. It's pretty basic. But users prompted for their credential. What's my username and password? And user types it in. And then that's sent over to the server. And the server takes that information and compares it against the database that they maintain. And when they do that, they're authenticated. And we decide that that connection, that interaction with the site is secure. But that interaction is subject to a lot of things, right? Key logging at the client. It's one way to steal passwords. Phishing, right? Oh, I gave my password away to somebody because I thought they were the IT department. The guessing, right? If I didn't use a strong enough password, if I didn't mix uppercase and lowercase, if I didn't add a symbol or a number, my password might be easy to guess. And lastly, I might be dealing with passwords that got stolen from somebody else's site, right? So they're vulnerable to a lot of these attacks. So what is a strong credential? If we're going to move people off of passwords, what do we want to move them to? What are the requirements here? And we really talk about it in three pieces. It's not breachable, right? So the password that I have is stored someplace securely that I can't just pull it out and take it away. Number two is it's not phishable, right? A lot of times what that means is that the user can't inadvertently give it away, which means they probably don't have it memorized. And then the third is it's not replayable. So when it's in transit, when I'm sending it from point A to point B, I can't be intercepted and then have it replayed back for someone to get access to the site. Three qualities. So fast identity online. This is a proposal that's been being worked on by a whole lot of people out in the industry, Microsoft among them. It's being worked on by two groups. The first one is the FIDO Alliance. And the FIDO Alliance, again, is just a group of industry experts, people across multiple companies, authentication companies, browser companies, people just generally interested in web security. And they produced a proposal for a way for site developers like yourselves to integrate strong credentials into their applications. That proposal then was submitted to the W3C, and they formed a new working group called Web Authentication. And that proposal for a JavaScript API is being standardized. So the industry has recognized that this is a serious problem and are looking to address it in the near term. What is FIDO? And FIDO 2.0 is the version of the spec that was actually submitted to the W3C. But it's basically a set of JavaScript APIs that allow for use of strong credentials in a relatively understandable way. It's meant to support lots of different authentication scenarios, particularly passwordless, so that you could set up a user account and a relationship with a user without ever having to store a password, or two-factor auth, something I may have and something that I may know or may be, like the biometrics that you see with Windows Hello. And then the third thing that they're working on is to support external devices. Where I'm showing you a PC version of this authentication, you may have a security token, a USB key. You might have something Bluetooth. It might even be your phone. Your phone, you might want to be able to set it down next to your device and have it be your authentication token that interacts with the website. So they're defining kind of a broad spectrum of solutions so that security providers, that website designers, you can pick and choose on what's going to work best for you. So let's talk about exactly how it works. You saw that we had a registration process where we have to sort of build up a credential and associate with the user. That starts with authenticating the user. And you can do that a lot of ways. You can do an account setup where maybe you have an out-of-band, you email the user a link, or you send them a text message. It might be that they already have a username and password that they're relatively comfortable with, and you just log them on with username and password. But once you've established that the person at the other end of the keyboard is the identity that you want to authenticate, the site can send down JavaScript to be run on the client called makeCredential. The function makeCredential in Windows will pull up the Windows Hello dialog. And as long as that PC has been set up with a PIN or a facial recognition or a fingerprint recognition, it will bring up this dialog in which they can unlock the secure credential storage. That's what the first prompt is actually doing. From there, we generate a public-private key pair. Right? Public-private key is kind of two keys that are mirror images of each other. What one locks, one can unlock. And those two keys are stored in two different places. First, we take the private key, and we store them into this Microsoft Secure Credential, right? Usually a TPM, trusted, protected module inside the PC itself. And the public key we can share with anyone. It's a public key, right? All it's going to do is unlock stuff that's been signed with the private key. So we send that up to the server, and the server stores that instead of some other weak credential. These keys are not phishable because the user, one, never sees them, and even if they did, it's this giant string of characters that well, if somebody can memorize them, they're a smarter man than me. So they're not going to be able to say, give that away. They never really see it. It happens under the covers form. But once we're here, we're registered. We have a key pair that's associated between the device and the user, the combination of the two, and the site itself. These credentials are origin bound, so they're specific to every site. We don't share them amongst all the different web developers. It's specific to you, and then specific to the device. The client can then register multiple devices, and each one will be able to log on with this experience. Once the registration is complete, then we have authentication. And authentication is simply that the site will send down a JavaScript that's going to call getAssertion, and then it'll send down a challenge. And a challenge is whatever you want it to be, but it probably should be a random number, so that every authentication is different, right, between people and between different users of the site. And this allows you to have a one-time experience of logging on. It's not going to be repeatable. Again, when you get this getAssertion call, we go ahead and we bring up the Windows Hello dialog, and we go and we authenticate the user, and we unlock the trusted computing module, right? We unlock the TPM, and we unlock the cert. So we go ahead and we pull out the private key, and we take this challenge and we sign it, right? We cryptographically sign it, and we create what's called an assertion. An assertion is basically just an authentication token that's been signed with that private key that is specific to this authentication because it contains the challenge that came from the server. So we take this assertion then, and we go ahead and we forward it back to the server. And the server can then pull out the public key that's associated with this particular device, and it can validate the assertion and make sure that it came from the challenge, right? So that it makes sure that that whole session works together. The only interaction that the user had to have was to put, in my case, the face in front of the computer and just make sure it's me sitting at the keyboard. They didn't have to remember a password. They didn't have to potentially give away any information. It's a very cryptographically strong authentication because we're using certificates here and signing. And it's not real breachable because we put the private key in a very private place, right, in a protected storage module. And it's not replayable because I can change that challenge with every authentication. I can even time them out so that they're only good for so long. So what you have now is a strong credential with two calls, right? Pretty easy. Make challenge, and then getAssertion. So we've already done that one. So when we have Microsoft Hello and Edge and this FIDO API, what we've implemented, and we implemented it starting with Windows 10, it was an early version. This was before the FIDO Alliance even submitted this document to the W3C. And we implemented it, one, to get familiar with it, and two, to just kind of be able to provide real feedback to the working group. It is tightly integrated with Windows Hello. So that means that right now, it only works with our trusted our TPMs, and it only works with Windows Hello. We don't support all of the other device types. But over time, the plan is, the long-term roadmap, is to go ahead and support this fully, right? And when I say long-term roadmap, we're talking about over the next couple of releases, where we're going to fully support the public API, where we will fill in a lot of the missing pieces. There's a couple of non-implemented pieces of the spec here, and where we will make sure that we match the semantics. The API that we have today is great, though, because we can actually develop a user experience. It's great for prototyping. It's great for understanding how this FIDO model is going to work. It's great for understanding how strong authentication can fit into your applications and websites. It's something that you can play with real code today. So it looks like this. It's not a super complicated interaction. But essentially, there is a make credential call. And that make credential call takes in a series of parameters. We're showing the two main ones. The user account information, it's simply metadata about who this user is and can be associated directly with the credential. Maybe it's their username. Maybe it's what they call relying party display name. So if I'm going to Outlook.com, Outlook.com would be the relying party. You can also specify a particular credential ID and other things into this metadata. The other is the crypto parameters. And the crypto parameters are essentially, we need to be able to associate how this credential was created. How can we use it? So what are the algorithms we need to use with it? What type of a credential is it? And the type is really a placeholder for the future when there's going to be multiple types of these providers, when we have USB and Bluetooth and all of these. One call, make credential, returns a promise. And out of that promise, there are two critical pieces of information that we need. The first one is a credential ID. Now, the credential ID we need in today's Microsoft implementation, but we probably will not need in the standard one when the standard is complete. The other is the public key. And you take those two pieces of information, you bind them up, and you send them up to the server for storage. The server needs these two pieces of information because when they call the next call, get assertion, they're going to need to reference the right key. The public key is something that you'll use later on to unpack the assertion. And like I said, the credential ID is something that allows you to reference which credential you want to grab. So the other half of it is get assertion. And with get assertion, we have to make a challenge. Like we said, it's best if you pick some kind of a random number generator and create a random challenge. And then you have a list of credential IDs. Now, you might have this particular user have registered with you on 2 or 3 or 4 devices. So you need to be able to send back a list of the credential IDs because you don't know which device they're actually on at the time. That list then will enable the client to look into their trusted store and be able to pull out the credential ID. Those two things are fed in, and there's a few others that are optional pieces that you can feed it. And it returns a promise. And that promise is basically the signature, right? That signature then you package up, and you can go ahead and upload it to the server, and the server can use it to authenticate it. Where the fingerprint is, when we make that call, that's when the Windows Hello dialog comes up. So when we compare what's in Windows today to where the spec is today and where we think the spec is going to land in the near future. First thing is that the Microsoft APIs are MS prefixed. And we did this because we knew at the time we were implementing an experimental API. This was primarily targeted towards prototyping. That will change over time. That is on our roadmap. The next is that we don't yet support the external credentials. And by external, we mean the USB keys, the Bluetooth, the phones, those kind of things. That also will take a little bit of time in that we still need some standards to emerge on how to talk to the hardware. Those things aren't in place yet, so we don't have something we can build off of. The Windows device today, your logged on user account must be configured with a PIN. And that's because the Windows Hello experience won't work unless we have a PIN protected identity there. Now, a PIN, you can extend it into facial and fingerprint, but at this point in time, with this experimental API, we're talking about you need to have a PIN configured. We don't support all the options. There's been some that have been added since we actually did this implementation. And those things we'll be bringing into the future. There's also a couple of minor semantic differences. And again, we will be fixing those and aligning with the spec as time goes on. And lastly is the piece we talked about. We actually require the server to send down the list of credential IDs, which means the server actually has to store them in this experimental implementation. This is something we'd like to remove because what would happen is that if you didn't have to store the credential ID, you could send down a get assertion with a blank list, and the client could be prompted to select the credentials for that origin that they want. That means that they could have, maybe you have an email account with Outlook, and you have the Rob email account, and then I have my personal email account, the Rob Trace account at Outlook. And I could get prompted for that, and I could select between the two without the server having to have foreknowledge of which account I was trying to log on with. Now, the server doesn't even have to prompt me for my username. I don't have to have that exchange. And the experience can be very, very passwordless. It can also be user accountless in the fact that we're not passing it across on the wire. By the time I select which account I want to log on with, I sign my assertion and send it back to the server. The server will be able to determine which account I'm trying to use. So it actually elevates us from where we are today with just using a strong credential to an even stronger piece where the username doesn't have to pass between the two. So the WebAuth working group is working very hard on this spec. They were chartered just about 6 weeks ago, 2 months ago. And they have already started revving the spec and done a bunch of the pre-work that they need to finish it. I highly recommend, if you're interested in using strong credentials, that you follow some of their work. There will be, obviously, credential enumeration we just talked about, and new authenticators. And then some of the things that we are missing, we do not have the extensions, ability to add extensions at this time, and timeouts. All of this stuff is going to be goodness, and it's something that we fully support. We're fully participating, and we're hoping that we can get in as soon as possible. In the meantime, it is a great idea to go out and experiment with it. So what we're doing is coming up later this week, we're going to have a blog post come out on Fido. It's going to include a deeper set of code samples. We also are planning on putting up a polyfill so that you can go from the MS credentialed API to the WebAuth standard API. And we'll also have a little bit of the server-side code for validating the assertions. So a whole bunch of stuff will come up there that you can take a look at. From there, hopefully, we'll also have a test drive. So this demo that you saw will be posting up on the test drive site along with the source as well, so you'll be able to play with all of that. And I hope that you take it up and take a good look at it.
Well done.